Okay, so today we are going to start chapter 2. We are going to see lesson 1 today, and it's going to be graphing and writing inequalities. So the first thing we're going to see is we're just going to warm up into these. You should have seen these symbols before, probably back in elementary and middle school. This one is the less than symbol. This symbol is the greater than symbol, and here is the equal to symbol. Now, a little trick, if you take your hand and you hold it out in front of you like this, in front of your face, everybody see my hands here? Notice what letter it looks like I'm making. L. So then if you sort of slant it a little, this is the less than symbol. So a little trick, so you can remember the difference between the less than and the greater than. Okay? Because if you read from left to right. So that's a little trick to remember less than. Less than starts with the letter L, and you could make, looks like an L with your index finger and your thumb. Okay, so here all it's asking us to do is compare the two numbers. So it's already got the answers here. And this one's pretty obvious because this number is negative and this number is positive. So we can clearly see that 2 is the bigger number and -3 is less than 2. Maybe back in elementary school, maybe your teacher might have added some teeth here and maybe like, or even like a Pac-Man, and it wants to eat the bigger number. So just remember that always the symbol wants to eat the bigger number, just a little trick there. Okay, so here, whenever you're comparing decimals, like on number 2, we're going to compare 6.5 and 6.3. If you wanted to line them up like this, let's say you didn't see it right away, notice the 6's are the same, can't compare there, but now we're comparing the 5 and the 3. And then the 5 is obviously larger, so 6.5 is greater than 6.3. On the two fractions here, on number 3, again, if these were the same sign, then we'd either have to make them decimals or find a common denominator or even do cross products. But in this case, one's positive and one's negative. So clearly we can see that the positive number 1/2 is greater than 3/4, negative. On number 4, though, we need to make them the same. So either make them both fractions or both decimals. So in this case, I could turn 1/4 into a decimal by dividing and make it 0.25, and then it's equal to. For 5 through 8, all they want you to do is take this number and see if you get a true statement when you replace x with that number. So in this case, is -10 less than 5? Yes, it is, so it's true. This one, if I put the 4.99, is it less than 5? Yes, it is, it's true. But here, when I do the equals 5, is this a true statement right here? No, because it's not less than, it's equal to. So that's why they put false. And then again on number 8, that negative number is definitely less than the positive 5, so that one is true. Everybody understand how these inequality symbols work? All right, let's go on. So in this lesson, we are going to be able to identify solutions of inequalities and to write and graph them. These are the 5 symbols that we are going to see that aren't equal signs. They're actually inequality symbols. The first red one represents is less than. The blue one is greater than. And the green here, it's sort of got a combination of two things. It's got a less than symbol, and it also has half of an equal sign. So this is why the statement says is less than or equal to. And then the same thing is with the purple, is greater than or equal to. And then the last symbol, it's just an equal sign with a slash. And this one means is not equal to. So just to reiterate about this symbol, it's like a combination of a less than symbol with an equal sign. So when we have a statement with that symbol, only one of them has to be satisfied. And what I mean by that is if I put 5 is less than or equal to 6, is that a true statement? Is 5 less than or equal to 6?
No.
It satisfies the less than part of it, and it only needs to do one of them. So because it does the less than, this is a true statement. Now, what if I said, is 5 less than or equal to 5? Is that a true statement? Yes, it is. It satisfies the equal to part. So both of these are true statements. The first one satisfies this part of it. And then the second one satisfies the equal to. It can't do both. So that's how that one works. All right. Now, I know this slide looks really intense here, but all they're doing here is giving you values of x, so the -3, the 0, 9.9, all the way up to 12, and they want you to plug them in and see if you get a true statement, if it could be an answer. So if I did the -3, so here are my options, x, then the x minus 6, then they take the x minus 6, and they want to see if after you do it, is it greater than or equal to 4? And then you say yes or no. So the first one, we're going to try it when x equals -3. So here they want me to take this -3 and put it in here for this x. So I'm going to do -3 minus 6. And I'm going to get my answer, and I get -9. And that's what they've written right here. Now, we're going to take that -9, and we're going to put it right here on this side. So now we're going to show, is -9 greater than or equal to -4? And because -9 doesn't equal -4, and it's not greater than -4, we will say that no, it's not a solution, because right here, this is a false statement. So what they want you to do is plug in each one of those x's to see which ones work. And as they did that process, they found out that the only ones that worked were these right here. The 10, the 10.1, and the 12. Everybody good with plugging in? Let's try the next slide. They're doing the exact same thing, but this time now it's 2 times the variable. So again, you would replace all of these for p and then test it out. So if I plug in p equals -3 into 2p, that really means 2 times -3, which is -6. And now I'm going to plug it in here, 2p greater than 8. Is -6 greater than 8? No, it's not. And that's why they wrote no. So it's just asking you to test out different solutions. Next, we're going to talk about how we can graph these. Now, when we graph them on a number line, we're actually going to show the direction of all the possible values for the inequality. And we're going to be representing with an opened or a closed circle. So on our next slide, this is going to describe the types of circles that we're going to put on our graph. So when I have a greater than symbol or a less than symbol with no underline, it'll always be an open circle on the graph. And that's what they're talking about in numbers, or the two first lines in the box. If it has the underline, then it will be a solid circle. And the difference between the two circles is the open circle tells us the starting point, but it doesn't include that number. But the solid circle means it includes the number. And I'll show you what I mean by that. So let's make a number line here. And let's say I have 4, 5, 6, and then here I'll put 3 and 2. So let's say I have the inequality, x is greater than 4. Now, when you go to graph an inequality, you're going to put your circle on the number that's in the inequality. We don't go to the next number above it or below it. So my circle is going to go on the 4, and because it doesn't have the or equal to, it's going to be an open circle on the 4. Now, I have to decide which way to point my arrow. Are my values going to be to the left or to the right? So what number, can I put a 3 here or a 5 here? Which way do I want to point it to? Which one would make it a true statement? Is 3 greater than 4, Kyla?
No.
No. Which one's it going to be?
5.
The 5. So I'm going to take and I'm going to extend an arrow from where the 4 is and point it in the direction of all the numbers that would make this true. Now, a little hint or a little trick, if your variable is on this left side, think of this inequality symbol here, this greater than symbol, as being your arrow. So here's the greater than, and then that's the pointing the direction of the arrow. It only works when the letter's on the left. Now, let me tell you why we put the circle on the number. Now, let's take the same thing. If I were to put 4 greater than 4, is that true? No. But what if I change it up? And what if I put 4.1? Is that true? Yes. Good. So the reason why I'm putting my circle on the 4 is as soon as it jumps off the 4, it becomes a true statement. Too many times I see students, they're tempted to put the circle here on the 5, thinking that 5 would be the first answer. But remember, we can have a decimal. That would be a true statement. So this is why we always start our circle on the number in the inequality. Make sense? All right. Now, if it has the underline, so let's say I have this inequality, x is greater than or equal to 3, then this would include 3, and that's why the circle is closed up. So if I put just some numbers here, put a closed circle on the 3, and again, showing it going to the right. All right, now let's look at this one. If you're asked to graph any fractions and a number line has been provided, just get it close to it. I'm not looking for precision. So for example, let's say on A, they didn't give you this. So let's say you had to make your own number line. And let's say you did -1, 0, 1, and 2. And you needed to graph 3/4. As long as you can get it at a reasonable spot on your graph, I'm okay with it. So know that 3/4 is a little bit more than half, but a little bit less than 1. So I could put my closed circle right about there, and then show that all the values are that way. So depending if a graph is provided or not, and again, you don't need to start your graph at 0. I'm okay with you putting the number you're trying to graph in the middle and then add numbers on either side. All right, so on this one, B, you need to simplify this first. Follow PEMDAS, and then they got it finally down to 10 after following PEMDAS, and then they graph the final result. Notice it's this symbol, so it's open circle, and it's going to the left. Here's another one. Again, it's a decimal. They've provided the number line with just integers on it. So 2.5 would be halfway in between the 2 and the 3. Again, it's an open circle, and it's going to the right. This one needs to be simplified first. And then again, we couldn't do the trick here because the variable's on the right. So just reverse the direction. Now, sometimes on some of the questions, you're not going to be given the inequality, you're going to be given the graph. So, what I recommend you do when you're given a graph and they ask you to come up with the inequality, do this first. Write whatever variable you want to define. Write the number where the circle is. Over here, I'm going to do the same thing. Pick any letter you want, put where the circle is, and now we have to figure out the symbol. Now, on this graph, notice, what kind of circle is this? Open. So we know it's going to either be this one or this one, right? And because it's going left, we want the arrowhead like that. Does that make sense? And then this one, it's closed and it's going right, so we need the underline. So the number in the inequality is always where the circle is. And you can pick whatever letter you want. Yes?
I understand how you can determine the sign based off the arrow.
Okay, so think of whichever direction. So let me see, let's erase. So on this one, if you, that covered up. So let me erase this thing. So you okay with just putting the X in the number where the circle is? All right, so then from there I'm going to look at the shaded. So notice this red, the line went this way. Notice if I take this arrow of where it was pointing and I take this symbol and put it here, the direction that the arrow was pointing. Make sense? Okay, same thing on this one. Notice how the arrow is going this way, so that's why I put my inequality facing that way. So take the end of the line and put it there. So that's a little trick that'll help you. All right, next one again. You're going to write the letter right where the circle is, that number, and then take the end of the line. And because this was open, it's just this right here. Okay, few words that are going to be important to us for the word problems. No more than, those words mean less than or equal to. Okay, so in my classroom, I have 32 desks. I can have no more than 32 students in my classroom sitting at a desk at one time. What does that mean? No more than 32 students. How many students can I have in my room?
32.
Good. So 32 or less. Okay, it could be 32, it could be equal to 32, but it had to be less. All right, the words at least. Those words mean greater than or equal to. My example for this is, and this is probably going to start becoming important to you as you guys are anxious to get your driver's license or your learner's permit. When I say you must be at least 16 years old to drive a car by yourself, what does that mean to you? How old must you be if I say you must be at least 16? Gabby?
Greater than or equal to.
Okay, greater than or equal to 16. So 16, 17, 18. You can be 16 or older. Good. Same thing could go with voting. You must be at least 18 years old to vote. So you could be 18 or older. So be aware of the words no more than and at least. Here's a word problem. So Ray's dad told him not to turn on the air conditioner unless the temperature is at least 85 degrees. Okay? How hot does it have to be before he can turn on that air conditioner? What would be a good temperature he could turn it on at? At least 85 means it's got to be pretty hot. So it's got to be, Melanie? 85 or higher. So the word at least is greater than or equal to, it could be 85 or any temperature above that. Now, in the homework, it's going to tell you define a variable and write an inequality. What it means by define a variable, it means pick a letter. So in this case, they decided to use the letter T for temperature, and then they showed that at least meant greater than or equal to, and then the 85. So when it says define a variable, you can pick any letter you want. Next one. This one also is using the words at least. So it said store employees earn at least $8.50 per hour. What does that mean to you? How much money could you make? Could you make $7? Could you make $8.50? Yes. Could you make $9?
Yes.
Yes, because it's at least. So you could make $8.50 or more. So your variable here, they use W for wages, and you could have used X, it doesn't matter. Just pick a letter and then make sure what they're looking for is that you understood that at least meant greater than or equal to. Then the last two slides have a few more examples. You can look over them and you can get some practice. Your homework tonight is 2-1 practice A. You must graph on some of them and write inequalities, and you must turn it in. It's due tomorrow morning before 8 a.m. Any questions?